I'm CK. Tonight we've got another one from Zlob Modular out of Chicago in the United States. This is their Trepanator. It is an experimental voice with dual VCO, random voltage feedback, EQ, and a state variable filter. So it's got a whole bunch of stuff plugged into a experimental, interesting instrument. And we've done other Zlob modules before and liked them pretty well, and this looks like it's got a lot of good soldering instead of surface mount, so that's good. So we'll take a look at the parts, put it together, put it in the rack, and see how it sounds. And I hope you enjoy the video. Here's the bag. Feels very hefty, which is good, which means it's got a lot of stuff. I picked this up from thonk.co.uk, as I do many of my modules, as you probably know if you've watched other things. And that means this went from Chicago to England, then back to me here in California. Kind of a long process for the poor little module. Let's pull out the circuit board and front panel first. He tapes these together. I forgot that. Two circuit boards and a front panel. We'll look at the front panel first, and as usual with Zlob's kits, we've got a rather ornate panel side, and we've got a plain panel side. So you can configure it the way that suits your style best. So what we've got is, as you can see, we've got 3, 4, 5 translucent panels on the back, which will shine through these little symbols. And we've got OS1 CV, SV fine. Here's the filter outputs, and that's the filter fine control, I guess. And this says 8/HIN. I'm not sure what that means. EQ out. So here's the outs for each part of the filter: low pass, bypass, and high pass, or band pass, and high pass. And that looks like it's the sum of the equalizer all out. Differ in, oscillator 2 CV, frequency. Those probably are knobs. Let me take a look to see if those are knobs or not. Trying to find where the controls go on this thing. Where did the controls go? Okay. I've got to turn it the right way around. So yeah, these two frequency holes are for potentiometers. And we've got a feedback switch with a symbol and EQ and so on. So I don't know what that quite is. And looks like some folding here, if I'm going to guess. HP amount, high pass amount, I guess. And here are 3 sliders for the EQ section. Then we've got a cluster, STH. Lots of abbreviations here that I'm going to have to read their little manual to see what it means. And this is S/HAMNT. Sample and hold amount, maybe. State variable filter CV in, or that's what this section is, I guess. Crossfade, 1 and 2 on or off. I think that's a switch. Yep, it's a switch. And then diff out, SV cutoff, which is a potentiometer. Resonance, attenuation, I'm going to guess, but I don't know. STH out. Again, some of these things I don't know what they mean right now, but we'll figure it out. Track and sample, is that a switch? Yep. And that's what we're learning from the front side. That's interesting. It says fade on this side, and it says crossfade on this side, and this one says lag, and it's slew on this side. So he's named them different things on the back panel too. That's interesting. Only a couple, not a lot. Now let's look at the circuit board, and as you can see, there's lots of holes. Interesting, the low and the mid frequency sliders are 100K ohm, and the high is 500K ohm. It's interesting, much more range on that. A couple of bicolor LEDs there. Another bicolor LED. Spacer. It looks, oh, stand-up resistors. Boo, hiss, stand-up resistors. Looks like everything has, on this board at least, has all the values listed. Let's look at the other board to see if that carries through there. Gosh, there's a whole lot of solder points that are very close together. So this is dated from, or dedicated to Hieronymus Bosch, 1494. You probably know his triptych, The Garden of Earthly Delights. But this is, he references here the extraction of the stone of madness. I believe that's trepanation painting from that time period that he took his inspiration from. Oh yeah, here's the, you can see there's a white background here showing a trepanator cutting someone's skull open to extract the stone of madness. I'll see if I can get an actual picture of the Hieronymus Bosch original painting. And as we can see here, it looks like we do have almost all of the values listed here. Bend caps to the left. Green mylar. Wow, he's really talky on the circuit board silk screening. Line up with the right side of the top PCB. Yep, we'll be doing that. That's a whole bunch of pin headers to connect. No, that's not all pin headers. Oh, I know what that is. Those are those resistor arrays, right? So that's 470 RA resistor array. These are pin headers, but these are resistor arrays, and we'll see those in a couple of minutes. Follow spacers for correct PCB orientation. That makes sense. This side bottom, that's nice. So it's got lots of good instruction on the board too to pay attention to. Very thorough. I love that. Let's see what's in the bags of parts. First we've got all our ICs. It looks like there are a bunch of TL074 op amps. 1, 2, 3, 4 of those. Then there's a ICL 8038. I don't know what that is. ICL 8038. We'll look that up too. Two of them. Probably something to do with the oscillator, I would assume. There's a 072 op amp. That's just 2 op amps in one package instead of the 4 in the other ones. And we've got this one, which I can't read really well. Then we've got an LM13700. I'm not familiar with that. So we'll look that up also. And we've got some hardware. We've got some caps. He's put the values on the paper. That's nice of him. There's the pin headers we're going to be installing, and some panel nuts and some screws. Looks like a transistor or a voltage regulator in there. I don't know which one it is. Transistor. Well, there are 2 transistors here. And more transistors here. Okay, so probably transistors, not voltage regulators, but he may have a voltage regulator on the whole deal somewhere. Then here we've got, floating around kind of loose, a bunch of resistors again. He's thoughtfully put the values on the piece of paper. Power connector. Our decoupling caps, 1/10 of a microfarad, 100 nanofarad, 104s that will go near all the ICs to condition the power a little bit for them. we've got other loose stuff in here. Again, there's a bunch of stuff just kind of lying or flopping around loose in here. Some more resistors. All the sockets. And then here we've got the resistor arrays, as I was talking about. Unfortunately, 4 of them came out of their slots, so I have to look them up. I have to take a look. I honestly don't know how to read the values on these. It's unfortunate that they fell out. I mean, I can figure 2 of them out because they go with another paired one, but the 20K and the 10K don't have a mate. So again, I don't know. These are generally a common lead with ganged to individual resistors. That's what these resistor arrays are all about. 104, that will go here. Then we should be looking for a, okay, this is, now I've just figured out how to read the values. This is 203, so that's a 2, a 0, and then 3 more zeros, so that will be 20K, and we'll go there. And this is 471, so that's 470 should be, yep, goes right down here. And now we're looking for a 10K, and we only have one left, and that's 103, so a 1 and a 0 and 3 zeros, so that's 10K. So that's how you read resistor array values. They kind of read like capacitor values. Put that bag aside. Here we've got all the pots. They're all good pots. They're all good metal green pots. The only thing that is not, let me check these sliders, see if they're the good slidey sliders. These are broader, wider than some. Oh, they slide very well. That's good. And then here we have the other thing where I'm always very interested in, which is the knobs. We've got some squarish knobs. That'll be sliders for the, caps for the sliders. They're plastic, just slip on. Then we've got plastic for the potentiometers. Nothing special about them. They're low-end caps, or knob caps. So that's all the bits and pieces. Obviously, we've got a couple of things going on. We've got a lot of parts to put on. And again, more critically, when we've put all these resistor arrays on here, we're going to have to be careful to not bridge between. There's a whole bunch of very close solder points. So I get the soldering iron heated up, and I'll look up these chips, or I'll do that when we come back, and I'll look up, see if I can find a picture of the original painting. Here's the original oil painting from 1494. As you can see, the Trepanator is taking the stone of folly or madness out of this guy's head, and in typical Bosch fashion, she's got a book on her head, he's got a funnel on his head. Bosch was in one of the very early Surrealist painters, so that's interesting. Now I will take a look at the chips. I didn't while we were away because I didn't take that long. It's a okay, the ICL 8038, it's a waveform generator. It's a monolithic integrated circuit capable of producing highly accurate sine, square, triangle, sawtooth, and pulse waveforms with the minimum of external components. Well, that's nice. That's why we've got 2 of them. Then on Zlob's website, we can look at the build docs, and we've got the bill of materials, build docs top PCB, build docs motherboard, manual, and a signal flow chart, which is really nice. So we're gonna, I think he wants us to do all the resistor arrays first, which is dandy. We'll do the 100Ks first, which are the 104s. And again, double checking them all to make sure they're all 104s. Because again, it's 8 pins, so 4 10K, 100K resistors in this array. So we're going to find this. That's the 100K with the 6 pin. This is the 100K with the 8 pin. I'm going to do each of these on their own. I'm not going to try and stack them all on and solder them all on. And as you can imagine right now, the resistor is leaning over right now. I don't care. I'm just getting it in position. And as you can see, it's very tilted. Don't care, because I will just do one leg and then reheat it and get it standing up straight. And there you go, now it's standing up straight. All the resistor arrays are done, and I mentioned that I made sure they were all as vertical as I could get them, primarily because if you look, the pin headers and things you'll also be installing, if these are leaned over, they'll interfere with them. Now we're going to do the resistors, and there are, most of them are stand-up resistors, as I mentioned before. I'm trying to find the ones that are not. Where are my 5Ks? Oh, are we doing 2K? Yeah, we're doing 2Ks. Where are the 2Ks? Oh, I already had them out. You could probably see them on the video, and you're saying they're right there. Now, 4 of them are stand-up resistors. One of them is a horizontal resistor. It's going to go between the 2 transistors. Where are these? It's going to go between the 2 transistors here. As he says, I insert the resistor about halfway into the PCB so it can make contact with the SVF, that's variable filter transistor, but isn't too important if the transistors are not matched and the 2K is not a thermistor. So this 2K is not the thermistor, it's just a regular resistor, but we'll put it in there anyway. That's the only, so we'll put that in. I'm going to go ahead and solder that right now. So it doesn't slip slide on me. Now we'll do our 2K stand-ups, and I'll do one of them with commentary so we can talk about stand-up resistors. So you take your resistor, if you haven't done this before, and you bend one lead over so it's parallel with the other one like that. And then if you look on the board, I'm going to zoom in. Hopefully you can see where this goes. There's a circle around one of the pads with a little line going to the other pad. So the way you want to do it is you want to put your resistor in with the body into the circled hole and the other one through the non-circled hole, just like that. All the resistors are on. As you can see, there are 9 of them on the control board, so don't forget those. Now we're going to move on to the capacitors. So all the 104s, the 100 nanos, in general, you'll find that they all go near the ICs. They are decoupling caps. They provide a little bit of power buffering for the IC. They also compensate minimally for any inductance in the traces and noise in the line. So the main thing is, as you're putting them together, even though he has great instructions showing exactly where everything goes, if you don't have that in your build guide on another project, just when you see a bunch of 104s, tenth of a micro, 100 nano, whatever you want to, however they're labeled, they'll probably go near the IC sockets. That's all the capacitors done, nothing too out of the ordinary there. He does, or the build guide author does recommend leaning these Mylar caps over to the left so there's no interference with the other, where's the other board? So there's no interference when you stack the boards on. I forgot to solder those caps. I'll get to that later. So I laid them down so they're about the same height as these foil caps. I think that should give us plenty of clearance. Whenever you do that, of course, you got to be careful not to push too hard, or you could break something. Next, we're going to put a whole bunch of sockets, 14-pin sockets on first for no reason other than that's the one we have the most of. Now we're going to start messing with power, or with pin headers, and we're going to start with the two 5-pin pin headers, which are going to make up the power connector, and they go on the back. Now we're going to do the pin headers, and we've got two kinds. We've got, of course, the male and the female. And where are the female side? There they are. They're in a different bag. Now I'm going to take the top board that this is going to go on to and line up. Try and line them up. Why are you doing that? Why are you dancing to the side? So now I've got all the male pins poking through, so that makes sure that when I stack this later, they're aligned. They're vertically identical to each other. I'll do the rest of those pins way in the future. But now I'm going to solder the rest of the pins on the motherboard. And there are all the pin headers on. And now we're going to go to our 3906 PNP transistors. Yeah, it's kind of interesting. He says, these parts are active and are sensitive to electrostatic discharge. Handle and solder with care. But he had them just dumped into the bag. Switches and panel nuts and washers and so on. So these are not all that sensitive. I mean, you should be careful, of course, but now we will do our 41/48. And for these, the black stripe is the one that will be touching because these are stand-up also. The black stripe will be what is touching the circuit board. So we bend the anode side, the non-black stripe lead over, like so, and have the black stripe side. Maybe you can see that. Maybe it's not focusing well enough. The black stripe side will hit the circle on the board. Black stripe side goes inside the circle where the heavy line is. And one of the diodes goes on the pots and knobs board. Now we're going to do our two power protection diodes, the ones that keep the thing from blowing up if you connect your power cable wrong. 4001, same thing. We'll bend the anode lead over, and the stripe lead will touch the circle with the line on it on the board to ensure we've got our polarity right. So that's the way it looks prior to putting the ICs in, and that's the next step for this board. All the chips are in their sockets, and I just wanted to mention briefly that there are two TL072s here. This one is suffixed CP, Charlie Paul. This one is suffixed IP, Indigo Paul. So make sure you get the right ones in there. I'm not sure quite why he did that. I don't know what the operational characteristics are different between the CP and the IP. I've never looked that up. But make sure you get it in the right place. Now we're going to solder all those pin headers I put on earlier when I was mating them with the motherboard. And there's all those. Now we're taking two 3-pin headers. I'm not sure what these are for, because, oh, we do have jumper blocks. Okay, so these are jumpers for some reason or other. Now we're putting the 200K trimmers. Okay, now we're going to put our spacers on. And now, okay, now we're going to put all the pots on. Let's see, what time is it? The cats want to get fed. Okay, I'm going to go in, feed the cats, and then we'll come back in and finish the front panel stuff. Make sure everything's settled in well. Yeah, I should have probably soldered the sliders on because they're less of a problem with the front panel being, not having the front panel on, but I didn't, so we'll have to deal with that when we get to it. Now the most fun part of any eurorack build, putting the front panel on and getting all our pots and knobs and switch handles and jacks to go through the right places. All the jacks are through, the switches are through, the sliders are through, the potentiometers are through, so I'll get my little clamp. Move that back a little bit. And that'll hold it in place while we're doing our thing. So what I'm going to do first is I'm going to do the sliders first. So all the components except the LEDs are now soldered, and while the cameras were off, I put all the panel nuts on too because nobody needed to see that. Now I'll do the LEDs. So we want to push them up against the little translucent windows that you can see, and what I like to do is I will solder, similar to what I did for some of the other components, I'll solder one leg. Oops, I will solder one leg. And I'll double check my position, and it is centered in the little translucent window. So I'll solder the other leg, and I'll do that for all of them. Some of them are harder to see. I mean, you can't really see with this armada of jacks. I can't really see this LED's position at all, so I'm just going to have to go with absolutely vertical is the best way to do it. So I will rest my middle finger on the pin to hold it vertical, and then I will solder that pin. That also means all the soldering iron heat is being transferred up that pin to my finger, and I don't mind that because I've burnt my fingers so many times soldering and doing other mechanical work over the last 60 years, 60 some odd years, that I really don't have any heat pain sensation in my fingertips anymore. It's kind of silly. Now these I can see a little bit, so I will get that oriented. Even though, of course, when I put a little pressure on it, it moves again, so I will just get it set and then do my eyeball verticalizing. So now we're about ready to mate the two boards, but before I do that, because there are so many components on here of various types, I'm going to go down the board and look at every solder point. All of them look real good. Now he is very, very I think he wants us to put the jumpers on now. Okay, so we've got the two jumpers that we'll put on before we mate the boards. Now that's interesting. That means I can't change the jumper position with the boards mated. I wonder why he didn't put the jumpers on this board. Just a design choice. Maybe he didn't have time, space, or he had another very good reason. So I'm going to put them in the default position, which is left jumper set up for EQ out and right jumper set down for audio into the stage filter. Now we will mate the boards, and he is very emphatic about making sure you get it right, and I certainly agree with that. I want to go ahead and put all the knob caps on. And we'll get our power cable, and there's where the red stripe goes, where the 12 volt, negative 12 volt rail is. So here's the front, and I am using the ornate side, not the plainer side, just because I like the aesthetic also. Here's one side. Here's the back, the other side, the top, and the bottom. Now we'll put it in the rack. I'm taking this out because I use a different connector. I connect it to my meter in the rack, my rack meter. We'll put it in the rack and hear how this thing sounds. It should be pretty interesting. Okay, we're in the rack. And let me go ahead and turn it on. One thing I do want to mention is I'm going to demo some stuff on this, but this is a really complex module. I'm going to move a box, there'll be some noise. It's a really complex module, so I probably won't get to everything, and some things I won't explain all that well probably. Go to Zlob Modular's website and read the manual, or look at the manual if you're really interested in this. And you'll get a full sense of what it can do. It can do a lot of things. One thing I do want to point out is while there is oscillator CV for 1 and 2, they're not volts per octave, and the oscillators are not temperature compensated, so don't assume this is going to be a melodic type VCO for you. This is a experimentation, very complex and interesting device, and I kind of like it. So for the calibration, as you can see here, and I'm going to go check on the camera just to make sure. As you can see, this is what we were talking about in the calibration. You want these two flashing slowly. So if I turn it down a little further, I stop it from flashing. You can see the left side is solid blue. Oh, it's flashing a little bit, but we want it to flash between red and blue. So I'm turning it up a little bit more, up a little bit more. That's a little too fast. I want it going like the right one. Now, that's where we want to be. Now, I'm just going to dive in here. I'm going to grab my output cable and put it in. Where the heck did the end of it go? And what are you doing here? Oh, also you may notice here, the voltage is it peaked at 52 milliamps, and we're getting 40, 50, 40 on A and 30 and 50 on plus and minus. So that's interesting, pretty low power. I'm going to go to equalizer out. You can hear it clicking a little bit because that's just the pulse from the frequency. Now I'm going to turn the frequency up on that oscillator, and you can hear it starting to make noise. And we can go to each filter output. I'm going to turn up some of this, going to turn up some sample and hold, turn up the cluster a little bit, give it a little resonance, and I'm going to go to track here. Turn up the resonance so it's self-oscillating. Now I'm going to go to actually, I'll go to the sample and hold out. No, that's not doing what I want. I'm going to go to bandpass out. Turn on feedback. I'm going to put some audio into the sample and hold. going to go to the filter in. Going to go back to sample and hold there, and go out to the sample and hold out, which I'm not getting anything out of. I don't think I understand it completely. So we'll go into CV for OSC1, and where'd I put my output? Put the output back in bandpass. That's with a ton of resonance. Let's just go to high pass out. I'm going to take CV into here. We're going to go to EQ out again. Go down to differential out. Put some other stuff in LFOs. Come back over here to sample and hold out. That's not giving me anything. Go back into EQ out. differ out again. I'm going to turn all the frequencies way up. And go back to bandpass out. So as you can see, and as I said, I'm not giving it a really great demo. I'm just giving it, basically, I've read over the instructions with the manual once and have played with it as you just saw. But obviously there's a lot to do with this module. It will be a great sculptor or pad or background ambient noise for something you're doing, or just pure noise if you want, noisy type stuff. I'll put some more sample and hold in here. So it's a module that you would want to spend a lot of time on getting it to a point where it's got interesting things for you. Obviously, there's a lot in it. As you saw, it's a relatively straightforward build. The build guide with all the pictures is excellent. Compliments to the author for creating such a comprehensive and picture-rich build guide. And it's a fun unit. And as always, I hope you enjoyed the video.